Today's lesson, we're going to look at inverse functions. In an inverse of a relation, remember a relation is just a list of ordered pairs, and it can be cool enough to be called a function if the x's do not repeat. But the inverse of a relation, the domain and range are switched. So if I have a function or a relation, it has this counterpart called an inverse in that their domain and range are opposites. So let's look at the example here. We've got a function on the left, the domain -4, 0, 1, and 4, range -2, -3, 2, and 1. The inverse of that, the domain would be -2, -3, 2, and 1. The range would be -4, 0, 1, and 4, literally switching the domain and range. Now, because we're switching domain and range, it means that the x and y values are also switched. So any point on that original function that was x, y is on the graph of the inverse as yx. So we're going to use that information as we look at the graph examples below. So number 1, graph the inverse of the provided graph on the accompanying set of axes. You must plot at least 5 points. So the black line is the provided function. There's a red dashed line that I'm going to talk about more here in a second. So we're just looking at the black line. I don't know why my eyes are gravitating here to this 0, 3 point. But on Delta Math, I would then go to where? 3, 0. 3 on the x-axis, 0 is my y value there. That's my new point for my inverse function that I am graphing, 3, 0. Let's switch colors here. Let's find some more points. Let's do over here, -2, 4. Okay, that was on my function. On the inverse, it would have 4, -2. So come into 4, plotting -2. Let's go over this direction. This is for 1 on the function. So on its inverse, we would have 1, 4. Kind of right there in the midst of my labeling already. Looking for 5 points here. Coming back here on green to -4, 5. So I'm going to have 5, -4 as another point. And one more. We could technically do 2, 2, and guess where it reflects back to? 2, 2. But I'm going to do one more maybe this way to give us a good picture. -6, 6 would be 6, -6, okay? So I'm going to trace this. Our inverse would go this way. Do you see it? So now let's talk about that red dashed line. That is where our line of reflection is. That linear function, that red dashed line, is actually represented by y equals x. If you think slope-intercept form, y equals mx plus b, that red dashed line has a slope of 1, and it's going through 0 as the y-intercept. So just y equals x represents that red dashed line. Think about it as well. We said that the x and the y get reversed or flipped there from the function to the inverse. So that is our reflection line. Whatever the y is becomes x. Whatever the x is, it becomes y. So just flipping over there, and you can see now that we've made our visual how that is flipping. So on Delta Math, when you see that red line, that can just help you visually see how it's reflecting over. Let's do it again on number 2. So on number 2, I'm looking and I see that we have a 0, -5. So on my new inverse graph, it would be -5, 0. This point is catching my eye. We have 3, -4, so I'll have -4, 3. What about, let's go here, -1, -6 would have -6, -1. We have 0, -7, so -7, 0, starting to get our shape here. And then I'm going to use 3, -8, so I have -8, 3 on the inverse. Let me trace that for us. that lovely parabola shape that's been reflected over that line of y equals x, all of those points, we just switch the x and y values there. Now, if you need to find the actual inverse function, I've got the steps here for us. If necessary, you may wish to rewrite f of x as y. I model that. I have some students that don't do that step, so that's up to you. We're going to switch our x and y values. Literally, we're going to switch the x and the y variables in our function, and then we're going to solve it for y, and then we'll write our final answer using that inverse function notation. F with a little -1 there, it's read as f inverse of x. And that tells someone else that looks at our work that we just found the inverse of the function f of x. So in number 3, we're going to find the inverse of the given function. We've seen this on benchmarks as just multiple choice questions like this. Super, super easy. We're just switching our x and y values in our ordered pair. So we'll have -4, -3, 2, -1, 4, 2, and 4, 3, right? Very simple. Number 4, we're actually going to find the inverse function of f of x using those steps that are listed. Again, I like to replace the f of x with y. Means the same thing, but that gets my brain going and thinking about I now need to switch the x and y letters. So x equals y plus 1 over 6. Now I'm going to use the rules of equality to solve for y. So first thing I need to do is get rid of that pesky 6 that's being divided. Let's multiply both sides by 6. I'll have 6x equals y plus 1. Continuing to get y by itself, subtract 1 from both sides. We have 6x minus 1 equals y. We have found the inverse. Let's just finish and write it in inverse function notation. F with the little baby 1 read as f inverse of x equals 6x minus 1. Final answer. So in the past, I've always taught inverses very early in the school year, and students kind of forget over time what it means to find the inverse. And I've noticed on multiple choice questions, students will just look for the different operations. They don't always look so clear. So we can see from number 4, it did have division and it did have addition. Our inverse has multiplication and subtraction. There are some inverse operations there, but they're not always so clear to pick out. And as we look at more complicated examples, you're going to see that come up. Number 5, f of x equals 3x plus 4. I like to rewrite the f of x as a y. We're going to switch our letters. X equals 3y plus 4. And now we're going to use the rules of equality to isolate the y. I'm going to need to subtract 4 from both sides. X minus 4 equals 3y. Divide away the 3 from each side. And we've got x minus 4 over 3 equals y. Finish it with our inverse function notation. F inverse of x equals x minus 4 divided by 3. Number 6, I'm going to rewrite that f of x with a y equals 3/5 x minus 12. Switching my letters because the domain and range are switched in an inverse. Solving for y, we need to add 12 to both sides first. X plus 12 equals 3/5 y. And then what you may wish to do is, instead of dividing a fraction by a fraction, multiply by the reciprocal on both sides of 5/3, and that is going to cancel out that fraction, leaving us with 5/3 times x plus 12 equals y. You could distribute that through and simplify it as 5/3 x plus the 3 goes into 12 4 times, and 5 times 4 makes 20 as a nice simplified final answer. Writing it in inverse function notation, f inverse of x equals 5/3 x plus 20, final answer. So look back at this one. Number 6 had 3/5 multiplying with our x, then minus 12. Is there a plus 12 in our inverse? No, we had plus 20. So remember these steps. Again, I've just had students in the past, they just look for opposite operations, but that's not always the case. You really do need to go through and actually solve for it. Number 7, I'm going to replace f of x with y. And so we have y equals 3 times x plus 9. Switching my x and y, sliding over here a little bit. X equals 3 times the quantity of y plus 9. We're going to solve for that y. It's in those parentheses. So first we're going to divide away that 3 that's being multiplied. X divided by 3 equals y plus 9. Subtract the 9 from both sides. And I'm just going to tag it along with that x divided by 3 to the side of it. Minus 9 equals y. And we're good to go. Write it in final answer. F inverse of x equals x over 3 minus 9. Number 8, replacing f of x with y. Switching my letters and sliding over here a little bit. X equals y plus 4 raised to the 1/2. Now, we've been studying those rational exponents recently, so you should recall that the 1/2 does represent the square root. If you want to write it that way, you could rewrite it as the square root of y plus 4. Or you may recall you could just square both sides to cancel that out. So however you want to look at that, we are going to end up with x squared equals just the y plus 4, undoing that rational exponent by squaring both sides. Or if your mindset is undoing the square root by squaring both sides. Lastly, subtract 4 from both sides. So final answer, we've got x squared minus 4 equals y using our inverse function notation. Inverse of x equals x squared minus 4. Number 9, replacing f of x with y. Switching my letters, I have x equals 7y to the 7th. I'm going to divide away the 7 coefficient first. X over 7 equals y to the 7th. Now we can undo that 7 exponent with a 7th root. So I'm going to take the 7th root on both sides. And we have 7th root of x over 7 equals y. This is my final answer. I'm going to write it with that inverse function notation. Again, that's a 7th root of x over 7. Number 10, replacing f of x with y. I have y equals the 4th root of x minus 2. Sliding over here to switch my letters, x equals the 4th root of y minus 2. I'm going to undo the 4th root by giving it a 4 exponent on both sides. So I have x to the 4th equals the 4th root and 2 to the 4th power cancel out, leaving you with y minus 2. I just need to add 2 to both sides. So x to the 4th plus 2 equals y. I'm done writing it in our formal inverse notation. We have f of inverse of x, x to the 4th plus 2. Number 11, replacing f of x with y. And then switching my letters, I have x equals y to the 5th over 3. I'm going to need to get rid of that division first. Multiply both sides by 3. We have 3x equals y to the 5th. I can undo the 5th exponent there with a 5th root. Those are going to cancel out. We have a 5th root of 3x equals y. Finished, and final notation, the inverse of x is the 5th root of 3x. And lastly, number 12, replacing f of x with y. And switching my letters, I've got x equals y to the 1/2 over 7. Solving for y, first get rid of that 7. Let's multiply both sides by 7 here. I have 7x equals y to the 1/2. You can think of this as 7x equals the square root of y if you want to, but we are going to square both sides to get rid of that. Showing both of those notations there. The squaring of both sides is going to cancel out that 1/2 exponent or that square root of y, and I've got 7x squared, the quantity of 7x squared equals y. We're finished up, so using that inverse notation, f inverse of x equals quantity of 7x squared. We do want to make sure we have that 7x in the parentheses with our squared. So that's inverse functions. Literally, the domain and range are flipped or switched, and so you can use that in a table, a list of ordered pairs. We looked at the graph. the graph, the image ends up being reflected over that line y equals x because our x and y are switched there. And then we had several examples of finding our inverses algebraically. Do switch our x and y and then solve for y. You're not going to see the exact same operations, just inversed. So do solve so you can find those precisely. Let me know if you have questions, and I'll see you in class.